nearly two decades of international experience in ecological modeling, wildlife survey methodologies, data analysis, and teaching. She holds a PhD in, PhD in statistics from the University of St Andrews in Scotland. And for anybody who is involved in marine mammal work and passive acoustic monitoring, they know that St Andrews is the basis for PAMGuard, isn't it? Yes. And she is the founder of Counting Whales, because that's her passion, to count whales. Her expertise encompasses distance sampling, bioacoustics, and the application of advanced statistical techniques to marine mammal research. By applying advanced statistical techniques to field data, she helps uncover critical insights into cetacean populations, dynamics, supporting science-based conservation efforts. Can we keep it central, please? Yes, thank you. Her career combines research, fieldwork, outreach, and teaching. Rocío is also committed to education and capacity building. With a master's in didactics, she leads training programs and workshops, advocating for hands-on applied learning in marine science. And, oh, there it goes again, sorry. And she works closely with NGOs, academic teams, and regional networks to bridge the gap between science, conservation policy, and public engagement. She believes it's our responsibility as researchers to engage with the public. And the first step to serve conservation is through education and awareness. Rocío, can I invite you, please?
Hello, do you hear me well? Okay. Well, first of all, thank you, the organizer, BGP Green Heritage Fund, Monique, to invite me. It's been a pleasure. I thank you all to keep here. Don't leave. Stay with me a little tiny bit. So I'm going to introduce myself. Monique did a pretty good job. I'm going to fill the gaps with some personal details. Who I am? I'm Rocío, and I'm going to be going back to 2008. Actually, I'm cheating. I'm going to be even farther. 2002, when you are in high school, and people are asking you, like, what you are going to be, what you are going to study, and you have to make your own first decision. That seems like the most important of your life. And at this point, to give you some context, I was doing synchronized swimming in a very high level, national and international competition. I was having fun weekly with my group scout, going into camps. I'm from Valladolid. Valladolid is in the center of Spain, no coast. And don't ask me why. I knew I want to work with dolphins and whales. But I have to study university, and if I don't study university, my parents will kill me. So for me, there were no an option. I love to study everything, and I was really good at maths. And I thought, well, if I have to study 5 years something, I'd rather study mathematics that are going to be easier, I thought very naively. And then I will figure it out. So I basically studied mathematics. I did 1 year of Erasmus in Lyon. Then I studied another master of statistics because I was not very unsure what to do next. And at the same time, I managed to have a teaching certification because I always loved didactics. So I've been teaching since I was 18 years old. And so far we have the maths, but you don't have many whales there. The whales arrived later thanks to a scholarship of La Caixa, that is one of the banks of Spain, and he allows me to start working in a bioacoustic team in Paris, where I learned tons about the acoustic of whales because I have no idea. I was a mathematician. I am a mathematician. I usually say, like, I have no idea of biology. I know a little tiny bit of the species I work with, but not many. And the good point of being in Paris is that the field work was in Guadeloupe. So I moved to the Caribbean around 2009, and I did, during 2 years, field work with these 3 NGOs. Bridge, that at this point was helping even, was the creation of the Agoa Sanctuary, that is a protection area in all the French islands, so Guadeloupe, Martinique, and Saint Martin, the French side. And Omag and Monicol Mabalen, that I keep ongoing work right now, because right now I'm living in Martinique, but it's been a long way. I did my PhD in St. Andrews. So St. Andrews, they were the creators of distance sampling. They're an amazing team. They create Penguin software. All the software are free, and they are super amazing teachers. So I was there for 6 years doing my PhD in distance sampling methodology. You will know a little tiny bit later. And during my PhD, I did statistics. No wells at all. My wells were simulation, dots that move. So I was a little bit sad, and as soon as I finished, I like, no, this is not what I want. I want to go and do some field work. So I moved to Alaska and collaborate with Alaska Well Foundation during 2 months. That was amazing to kind of compensate my 6th year of no wells. And then I moved to Barcelona, where I was studying 2 years in another bioacoustic lab. I was back to research, but it was not very cetacean involved. And in Villanova, where it was based, there were an NGO, local NGO. I always been collaborating. I try to make it in 2 sides. This is kind of my academic size. Do you see them? Yeah. And this is my cetacean side. And I did some work with the Prieto rockwall, that is the main species in the Mediterranean. And basically I quit my job because I said, there is not enough wells, this is what I really want to do, and I managed to mix them with the creation of counting wells around 2024. So I moved to Martinique in 2022 and started working with the CCS, that was the Caribbean Cetacean Society. It's a local NGO based in Martinique, and I'm going to tell you a little tiny bit. I keep involved in university teaching in the ISEA, which is the university in Martinique and as well the public one. And that's what we did in the CCS. So at this point, I really managed to link both of my passions completely and live from that. We were doing expeditions in all the Caribbean Arch. So there were 3 areas, north, center, and south. And all of us live from Martinique. And we were 15 days every month in a catamaran teaching people how to collect data, why it was a good reason, why we were following this methodology and not this other, and explaining. And in August 2023, I have the pleasure to meet Monique. So Monique is here. That's me with a long hair. And I was expedition leader. We stayed 15 days together in 2 rotation groups. We went from Martinique to all the way up and coming back. And I was in love with this lady. So we keep ongoing collaboration until right now that I managed to be here in Suriname. So I'm very, very excited about this opportunity. And that's more or less it. So what I do now with counting wells, I keep doing research. So I publish things. I keep doing theoretical and practical training, mostly workshops and things like that. My new adventure is doing online courses because I discovered that my entrepreneur, so my company, doesn't give me a lot of stability. There is some projects and then no, so I'm trying to give myself a little tiny bit of structure and stability through online courses. I will tell you how it goes in 1 year. I keep doing education, supervising students, working. I do a lot of hobbies. These hobbies are paid mostly for consulting, like MMO, so it was funny. I was about to ask you, like, will I send my CV? You should ask this question to the NAST. And data analysis, telemetry data, photo ID, a lot of population size estimates, that's more or less my expertise. And I love keep doing awareness and outreach, as Monique said. So that's me. The good point is like I'm allowed to work with partners that because I have all the flexibility to choose my partners, they usually share my same values and they become friends. So that's a sweet moment for me right now because I'm doing what I want with the people that I want. And this is really, really important. So here are a lot of friends. Greenery and fun. There we go. So now I'm starting business. How and why is important the survey design when we want to get a population size estimate? And, I put these two logos from CREAM and the University of St. Andrews because I'm borrowing some of the slides. This material is like some I personalize with my own examples, but some are really from their technical courses and everything. It's everything online, but I think it's always good to credit people. So the question that usually when you are dealing with conservation is mostly asked is like, how many animals are there? And it's very simple to ask. It's not that simple to answer. It's a big question. We need to have a solid basis to be able to give some numbers. So the goals, estimate the size. When I say abundance is equivalent to density. Density is just like the number of individuals divided by the area. So completely equivalent. And we need to quantify the uncertainty associated to this estimate. How much I can trust this estimate. It's not the same. I have a group of 20 and my uncertainty is between 15 and 25 than if it's between 10 and 200. So I need to know, okay, in which values I am moving comfortable. Additional goal can be multi-species surveys. That is most of the case when you go offshore and you have a lot of species. It's always good to have a visual representation through a map because you can see how many animals there are and where they are. And one very common goal is like, could you tell me if the population is increasing or decreasing? How are they doing? So we can measure temporal trends. Okay, how we count animals. All of you are going to make the effort to think that your beautiful and complicated study area is this square blue. Simple. Imagining first method, you count everything and you are able to survey everything. So whatever we are counting, it can be whales, dolphins, trees, whatever object you are. I'm counting whales because I like whales. But you can count whatever you want, the methodology holds. So these dots are these. We can use to cut the slots. I saw my first one yesterday. We imagine, we survey everything, we count everything, so our number in this square is N 200. And the density will be this number divided by the whole area. You can say, okay, Rocío, a piece before that. Well, usually it's not very realistic. You know, you can most of the times not be able to survey the whole survey area. So you need to survey some specific park. And in this case, we are still assuming, plot sampling, that we count everything on the area that we are covering. So we can plus some lines. You can see the lines in blue here, or dots, circular plots, street transit. And on this area, we are able to count all the animals that we see. So the idea is very simple. Keep with me. You count everything in this little color area, and once I have this number, I'm gonna escalate to the whole area. How I do that? Well, basically, I need to locate my transits in a very clever way, or random or systematically. Why? Because it's a decimal base. I need that my sample are going to be representative of the whole area. So I cannot say like, okay, I got a call and I know it's there, or look, I live just near this road. No. It needs to be representative of the whole area. So some parts are going to be easy, some others maybe not so. And it's decimal base because based on this survey area, you are going to scale up to the whole survey area. Study area, sorry. So the abundance have this formula. No worries about the formulas. Keep with me. This usually is not very realistic neither, because what happens is like, are we able to count everything in the area that we are covering? Most of the times, no. So we need to add detectability. And to detect some individuals in the cover region, if we measure this detectability, it's going to allow us to account for the missing one. So as you can see, right now in the lines, it's like line transit and point transit. I have a wider region because I'm not assuming I have to detect everything. I can see a little bit further because some of them, I'm going to miss them. So you can see here, there are some dots that are red and some that are still black. I miss this guy. But how am I going to account for it? Well, you need to add this probability of detection. So still, for the purpose of estimated abundance, 2 steps. I'm going to assume I count everything on this area. The problem is like, okay, if I'm allowing myself to don't detect all the animals, how I'm going to count everything? Estimating this probability of detection, which is this P that appears here, which is the proportion of animals that we are detecting or the proportion that we are missing. And once I have this, how many individuals are in the area that I'm covering, I move to the whole study area. So still decimal base, I need to make sure my samples are well placed, randomly or systematically, to have a good representation of my whole area. And so far, you are believing me that we are estimating this P. How we estimate this P? 2 main methodologies, forever, and for all the methods, but I'm explaining right now on cetaceans. Distance sampling, most common use methods. Why? Because it's very simple. The only thing it needs is the distance. And it's the PSD of my subject. So basically what we are going to do is like we are going to walk the line, and every single detection we made, we are going to record the distance. We are going to plot the distance we are recording in this histogram, and it makes sense. At fewer distance, we are going to see much more animals, and as I move far apart from me, I detect less. Completely logic. And I'm going to model this histogram to estimate this P. That's the idea of distance sampling. I'm not entering there, but basically, you are fitting a model, is why it's model-based, and you get this proportion. 50% of the animals you are detecting, 50% you are missing. An alternative to distance sampling, mark recapture. Usually the methodology is capture, mark recapture, but in the case of cetaceans, they are very nice. They came already marked. So we don't have to capture them, we just need to take pictures. And with the photo ID, we have the fluke of a humpback whale. It works as well for sperm whales. They are like fingerprints. We are able to identify completely individually, so we are able to track. And exactly the same with the dorsal of the dolphins. You can see there are like, Monique showed us exactly the Hawaiian dolphin. We are able to say, okay, this is Peter, and I know Peter have been this day, this time, here and there, so we are able to track them. We can do as well this with genetics. It's what's called closed skin methods. So basically we are able to identify individuals. As soon as you are able to identify individuals, you can apply capture-recapture, mark-recapture, to estimate this P. The idea is estimate this proportion of animals that you are missing. Two main methods to estimate this P to get the whole abundance. I'll put you a quick example just to show you. These are bottle dolphins in Guadeloupe, and I want to present you Rocío. He was born in 2009, and I was doing field work, and basically in the association that we were working, that it was OMAG and Monicol Mavalen, they used the kids to name the dolphins that were about to be born. And we were in this expedition, I was there, and it was like, oh, maybe we have chance and we see the baby dolphin. We didn't. So I came back to Paris working with my call, and 2 months later, they told me, we found him, and we named him Rocío. So I was so happy. It's like I have my little dolphin swimming in Guadeloupe. And that's him, baby, baby, baby. I need to find a new picture of the dorsal. Have been seen for the last 2 years, so they recommend no naming the dolphins names of people, because sometimes they appear and it was like not in the best conditions. So it's like, oh, Rocío is dead. Rocío is not dead. I think he's traveling. So maybe he's here around. And his dorsal was completely destroyed after 3-4 years. So they told me like, it's a water dolphin. He's on adventure going. So, yeah. Back to business. We have our P. We estimate it. Still, why is important the survey design? Because the first component is like, if I need to estimate how many animals are in this survey area, I need to make sure our sample, our lines or points are representative. So we need a good design. I cannot strengthen enough the important, because if you don't have a good design, you cannot build up the whole density on how many individuals are in this study area. It's mostly impossible to compensate for poor design at the analysis stage. I didn't realize how important it was, because I was studying my PhD in St. Andrews, and people arrive with plenty of data. Okay, we collect this data, we did everything, 10 years of data, amazing quantity and effort and money. And it was like, we want to see if we can answer this question. And the short answer, it was like, no, you can't. Because it's missing this little thing that we need to estimate this probability of detection. Or so, completely free advice. If you want to plan a survey, make sure you fix your question of interest the first thing. Because depending on that, your methodology is going to change completely. Of course, when they bring us data, we can cook and do some recipe, and it's always viable, and we are able to extract information, but more of the time, we cannot reach the population size if we are missing some information on some data. We cannot do magic. We are a statistician, and of course you can make it run and get numbers but no value at all. They will have the same value of me playing bingo. So no. Survey design must have a random component for both methodology, distance sampling and capture-recapture. So even photo ID, that some of the times they don't have this random component, they should include it. We are assuming this on the methodology. And you need a pilot survey. Your first survey is going to be what is going to give you the tone. Of course, if you don't have this model, if you don't have, this representative area, you can replace design assumptions with a model. And in this case, you can have a map, which is called density surface model, that is going to give you the number of animals and where they are. That's even nicer, but you still need to deal with detectability. So, pros and cons of these maps. Well, the pros, if you get a map, that's the first one. You don't need a design, so you are relaxing one of the assumptions. You can explain variation between lines probably with a small variance. That's kind of technical. I don't want to enter there. But the cons is it's going to be less robust to design-based methods. It's more complicated and it's sensitive to the model. And you can always, you have to always show your map with your uncertainty to match how much can you believe these estimates. So, okay, it's important. How do I plan my survey design? Now I kind of convinced you that it's very important. How to do it? Well, you need to know these kind of ideas first. What are your objectives? What precision do you need? If you need some estimate with a 10% of precision, or it can be larger. What resources are required? Your cost, your budget. Because you need to know what is the cost of the boat, if you need to go 3 days, what is the cost of the petrol, everything you have to include it in this stage of defining the survey design. Statistical advice, important, because at this stage it's going to cost you a little tiny bit, but it's the good moment. If you seek for the statistical advice, once you collect the data and everything, probably a couple of things that can be tweaked have already done. You pass the opportunity. So conduct a pilot survey. If you don't conduct a pilot survey, your first survey is going to become your pilot survey, because you need to have this idea of what is my encounter rate, things that you plan even with the perfect planning. I've been doing this a long time. I keep discovering things like, damn, we didn't think about it, because it's very logistically dependent on the area, the boat, the place, the community. So you need to put yourself in the situation and say like, okay, these are my problems here. Good news. All this can be done by simulation. So basically, to have a good survey design is easy. There is a package in R, completely free. It's called DSSD, Distance Survey Design, and you can check it. So basically, a couple of days in front of your computer, and you can know if your survey design is going to be okay or not okay. Here are some examples. Points, lines, systematically placed, or, well, here we have no random. I'm going to show you the idea key on survey design. And basically, what we are asking for a design is that they are representative. And we are going to play with two main concepts. We are talking. Perfect. Oh, sorry. So, uniform coverage probability, which is the probability for a given design that a point I painted in red within the survey ranges will be sampled. And both of these designs have the same probability. The only thing that changes is for a given replica, so for once, the design which is systematically have a better even coverage for one replica. But if we do it and do it and do it, on average it's going to be fine, both of them. So it's why we always said go random or systematically. If you have to choose, if you can choose, go systematically. because that assures that you have a completely even coverage. Okay, or random or systematic. I say it already 3,000 times. I hope you get this when you leave. It's like, this is my take-home message for the hour. Common mistake, using roads, tracks, because it's convenient. But a road is going to have a attraction or a go-away effect. So you shouldn't be using this kind of already defined path to surveying. Stratify the study area. Sometimes we have like different patches or animals. You can stratify. And other than you stratify is like in this example, that is just because of logistic. If I don't stratify, you see, I'm going to use this whole convex polygon. And my own effort is like I'm going to be looking, but here I'm not looking because I'm outside. These lines are outside of my survey region. So basically, I'm going to lose out a lot of money. And in this case, you can stratify to make the shape of your study area, that usually is not the square I saw you, and optimize your fuel, your boat, your airplane, whatever you are doing. We want to orientate the lines always perpendicular to the coast or perpendicular to if there are some gradient of animals. So if we know the coast is like this, one common mistake is put it in parallel. Because some animals are going to be more in this deeper water or not. So that's the good thing about putting in perpendicular. You are going to cover equally. And we rather many short lines than few long ones. It helps with variability. I put you this example, I like it very much when you are doing multi-species. In this case, there are two species. One is rhizo dolphin and the other is harbor porpoise. And as you can see, the rhizo are much more far away from the coast and the harbor are always on the coast. So in this case, you can stratify as well because probably, the intensity that you're going to find both species as different. So you can put more effort in this area because it's convenient for my student or because I have more interest in knowing what's going on with rhizo's than with harbor porpoise. Why simulate it? It's less expensive, you can check it, and once you go on the field, you know you are doing right things. So it's kind of the first step to say, okay, this is what are we doing, and it's going to work. Now I have to handle all the troubles of the logistic on the crew, but not on the statistical aspect. You can see when things can go wrong, when you have a tricky shape or a corner that is not very well, you will see that this is not getting problem. And you can as well have some patches. You know, you have hot spots of this species in this area and this area. So I'm going to get more detections if I place lines there and there. You can use this because basically for distance sampling at least you need to reach some minimal numbers. So survey design and this simulation can help you to guarantee that at the end of the survey you don't finish and say like, I have 3 detections, I can't do anything. I have information, no, that allows you to prevent all this and be aware of it. This is what I was talking. This is where we are looking for some even coverage score, coverage probability. So we don't want to have very high or very low, we want to have kind of the same color. So that's okay. This, for example, because they have this little corner, they do stratify and do these 2 different stratas, and we can see in the simulation that this is not a great idea. So probably this design is more efficiently, costly, but on the results, we are going to get some errors associated to this design. So if I have to choose, and we can choose because the money is more or less equivalent, and because it's a simulation, you will know what is the length of your survey, so you can say like, running again until I have my perfect shape. It's like, that's perfect, I can cover, I have the distance, I have everything. I will choose this one. I hope this speaks to you a little tiny bit more. I'm going to put you some really example. All of you know this is the coast of Suriname. Monique, correct me if I've said something wrong. And we were aiming to reach the 30-30, which is protecting the 30% of our oceans in marine protected areas. But to be able to be a marine protected area, you need to be qualified like an important area, which is IMA. Am I right? It helps. I'm lost a little tiny bit with the bureaucracy. Anyway, here in Suriname, Monique told me like, we don't have enough data. It's missing. We are not able to be considered because of the lack of data. So we said, okay, let's try to make this happen. And we were trying to reach this. This is a deep canyon. So it's very interesting because all the deep species can be found there. Sperm whales, big whales, I put you 3 examples of big whales, but they are not easy to see. They spend on average 1 hour underwater. So far away, you don't have the easy sea here. The weather conditions are not the best. It's not like in other areas. So basically we need to go offshore and do some transit. And I put you an example of what we did. We create 2 strata, so basically this translates to this, to be able to cover with a much more intensity the canyons when we think the presence of the deep divers will be, and be a little tiny bit more gentle in the other strata to see what's going on and collect this data. I ran the simulation and all of it, I should put it, but I tried to run it yesterday and it took a long time, so I went to sleep before it finished and I was like, okay. You believe me, it was very well covered, it's the same color and everything was fine, that's why we did the simulation. So if you have where I can find more, I want to know, there are a lot of exercise with free code and everything. This comes from San Andreas and it's amazing. You have my email, so if you have questions or whatever, you are more than welcome to reach to me. But there are so many available materials, so I always put this in case people are curious and want to spy And just to wrap up, simple is often safest. Equal coverage and ensure that data are representative of the population. So in this case, we can give some population size. And the sample, the analysis, the sample, the design, the sample, the analysis. Usually goes always. Stay with me 2 seconds. This is kind of the main thing, but I feel always a little tiny bit sad that when I introduce what really need to have a population side, it's like, I don't have this data. I cannot do anything, so I have a couple of little hope with other ideas that is like, your data doesn't look anything like your design, there are still plenty of things you can do. So, no panic. You don't have a design, there are options. If we have an effort, we have observers that have been actively looking on effort, then you have this extra information. The other case is like, no, you don't have any effort. You have data collected by a network of fishermen that they get some observation, what they're looking, because that's not their main job. So they're doing their job, and thank goodness they see something, and it was like, I'm going to call Monique and tell her that this day, at this moment, I have this observation. I cannot do anything with that. Yes, you can. So if you have effort, back to the CCS, we were traveling all around the arch No survey design. I was telling to my employee, the director, do a survey design. We are stuck on, and Lucas, that is there and basically sent me a lot of kisses for you, Monique, just published last week. We get the news, so it's very fresh. A paper on the Freser dolphin, Freser. So that was his master thesis. He's one of my students, and that was the track that we did. You can see nothing like a survey design, nothing that I can tell you representative of the area. This area, Atlantic side, never been covered. We are trying to extrapolate what's going on there without being there once. But we have plenty of observations, so what we can do? We are forced to be playing with models. And a model will look like this. Okay, my study area, I will put a grid. This is my track, my boat moving around. Do I have some way to track detectability? This detectability is going to be the P I was telling you at the beginning, this proportion of animals. That's a tricky part. Sometimes we cannot. Sometimes he needs always some kind of information about the location, the distribution of where you're seeing the things. Then you have your effort, which is your book. This plus this is going to give your effort. Your observation, how many individuals I see for each of the cells, and the environmental variables. Because I'm interested to link this, the model is going to link me, so I get some extra information. And these are the results. I'm going to show you very quick because I don't want to overstep. But this is the habitat suitability for the Freser dolphin, and nearby we have the coefficient of variation that tell me where are the areas that I'm completely imagining thin and I cannot rely. So there is a big red area here. I'm very surprised that still the Pacific side are not that bad. But that was good because we get a lot of data here collecting in the range of similarities. So this linked to some variables. I saw you another example. I have 2 more and that's it. When we don't have an effort. So this is a networking. This is Omega. This is a poster we presented. And they managed to have, I'm talking about, they started when I was there in Guadeloupe in 2009. So I was basically in 6, but officially the NGO was created in 11. Until now, and it's a network, collaborating people. They do for fun. None of them is their job. And they have a catalog of hamper whale of more than 800 individuals. So this year, these are the data from last year. I didn't update the new one. They collect as well 70 individuals, 68 I think. I got the email 2 days ago. And basically, no effort, no survey design, but a huge catalog of hamper whales that we are able to identify. So we are able to do capture, markup, recapture. The second methodology. Estimating this probability is going to give us the mortality rate, the survival, and we are able to give some numbers. And are around 5,000 the population that passed by at some point were a variable during this study. That's the first population site estimate in the Caribbean for humpback whales. So this is a completely citizen-sized project, which have a lot of values, and sometimes people say like, oh no, but you cannot do much with the citizens. You can do a lot. You need a lot of data. I mean, these are a huge amount of data, but it's a question of time. And it doesn't cost much, it's just to build this network. So, and this is an example. This is the poster that I want to show you a sum up. Exactly the same. I don't have an effort, I don't have a boat, I just have observations that we download for GBs, OBs, online data sets, and Jaime Bolaños, which is CWOP, and he's another amazing network, and I'm very well surrounded of very good friends that do very well networking. And these are all our observations. No idea of, and it came, I should put the years, but it was probably 20 years, from 28 to nowadays. So even without this, we went for a Maxent model, which is maximum entropy, but we are able to do a map. Last thing, but very important thing I want to say, this map doesn't show how many individuals there are. It reads where are more probability to encounter these individuals. So we have to pay attention as well to the legends when we do the analysis, because this is habitat suitability. We are linked the covariates that drive the presence of rhesus dolphin. Perfect. But we won't be able, without a survey design or through a model, to estimate the number of individuals. This doesn't read on how many rhesus dolphins are in this area. So, last thing, this is a map. I'm telling you, you have to make sure what you are presented. This came from 1539, and there we go. That was the representation of cetaceans. Okay. And we have a balena, an orca, a Cepheus, and a vaca marina. There we go, Natalie, even for you. So, it's a map, but we need to know what is representing in the map. So, thank you very much. I'm not very active in social media, but I'm becoming. That's my goal, as well as LinkedIn and all this. You have my email. Well, I didn't put my email. That's not very clever. But it's counting.wells@gmail.com. And if you have any questions or whatever, well, you can always follow me. They will have plenty of maths and wells and a mixture with friends. So thank you for listening, and I'm happy to answer questions or whatever.
Thank you. I wish you had been my mathematics teacher at school, because I don't think I was bad at mathematics, but I didn't see any use. And counting whales, I think, is good use of mathematics. Are there questions? Yes.
Thank you. Rocío, my question is regarding seismic surveys. Some of them are, well, all of them have lines where the vessel go through, and you usually have observers during the day, and you have acoustic monitoring during the night. So most of the species are vocalizing can be identified at night, and all species possible can be seen during the day. Of course, we have a source, so maybe some species want to get away from the vessel. We don't know. But is it possible to estimate population in a survey like this? Yeah, in a big vessel with all observers.
Yes. Good question. There are plenty of studies that have been done with opportunistic. It's not the main goal, but because there is a ferry, so we always have to, but in this case, you are following transits. And the observers are doing, it's basically what we do on a normal basis when you want to estimate abundance. So if you go for distance sampling, even better, because you can always go for photo ID, but photo ID is more complicated because you need long term. So with 2 seasons, capture-recapture, you won't be able to estimate a proper abundance estimation, a population side. But distance sampling, you get it. You need the numbers. So you need at least 60 observation, which is tricky. But with cetaceans, things have been published around 20. Because we are gentle and we struggle to get the numbers up to 60. So one thing is the recommendation, another thing is reality. One of the hypotheses that I didn't enter right now, but is violated, is like you assume perfect detectability on the line. So in the line that I'm looking, I'm assuming that all animals that are on the line are going to be detected. In the case of cetacean, it's not true, because it can be 2 kilometers down on the line and you miss it. So what that we do is a double platform, and this type of vessel that they are huge, that allows, the only thing you need is like double your observers, so have 2 independent teams that they doesn't see each other or communicate with each other. It needs to be like, I always think that I probably struggle to be one of those observers because I'm so excited that it's like, it's going to be difficult to don't say to the colleagues, it's like, look! But, you know, it's supposed to be independent, you see, and with this double observer, you use with it's called capture distance sampling. You include this marker capture with the both platforms and you estimate it. So it's completely feasible. We should talk.
Yeah, so we've been working for many years with a marine biologist, Marijke de Boer, who did her PhD on actually platforms of opportunity, and she was allowed, for example, to use the data from the Tullow oil seismic surveys for her PhD. So it's available online. I can send it also to you. Yeah, yeah. Other questions? Well, we'll get Rocío back here like some of the other people we've had here. Yeah, there's one more question. Yes? No, you have to come to the front, yeah. For more teaching, actually.
I wrote it down again, else I go all the way. Because we spoke yesterday, so it's a bit about today. I'm sorry. So I told you yesterday I'm not very strong in mathematics, but I believe that when math is told well, it becomes a powerful story. Could you share what the numbers you collect from whale counting tells you, not just scientifically, but also as a story of the ocean? Yes.
I could, but it's not gonna be short. We should talk later. But yeah, one of the things that I learned more about the ocean and everything is really on a personal basis through all my life and career, because I kind of built my path. So I always get so many messages that it's important message. But yeah, it will be another talk. I talk to you later. Thank you very much.
Thank you, Rocío. Yes.
Where is your volume? I have it.
Oh.